Okay, hello everyone. My name is Mikola Servetnik, and in this tutorial I will tell you about 5G new radio, the next generation wireless access technology. Our first lecture will be the introduction, and let me start with the 5G evolution. So on the picture here you can see something I call per decade trend, which means a new generation of the communication was developed after 10 years. So in the 1980s, analog wireless networks, known as 1G, started to appear to allow voice communication over the air. That was the main purpose. Then, the fast development in 1990s, it was replaced by the digital version of cellular networks, which we call 2G, and it also gave a boost for new services. For example, that's the time when digital encryption started to appear and also short message service, which is known as SMS, were born. So then in 2000, we have a third generation of the wireless access technology, and it took advantage of WCDMA and CDMA 2000 technologies, and it brought us a new data services such as internet access, video calls, and mobile television. Those applications have boosted the development of digital devices, smartphone, tablets, laptop, and then after another decade in 2010, so just 10 years ago, 4G or long-term evolution LTE has brought us a great quality of experience and also quality of service by providing a broad coverage and high-speed mobile data transmission. So following this trend, 5G is launched in 2020, so last year, and it brings us even higher data rates and enhanced low latency and ultra reliable connection. So today the main player, the main organization that is developing a technical specification for mobile communication is called 3GPP, is called Third Generation Partnership Project, and they make documents which they put in open access, and those documents are usually called TR or TS, and they start with the 38. So TS is the technical specification and TR is technical report. So for example, TR 38901 is the 5G NR channel specification. And in my tutorial, I will often refer to those documents because I will show you some parameters, some algorithms that are clearly described in those documents and in many, many more details. All right. So the discussions on fifth generation mobile communication began around 2012. In main discussion, the term 5G is used to refer to a specific new 5G radio access technology. However, 5G is also often used in much wider context, not just referring to specific radio access technology, but rather to a wide range of new services envisioned to be enabled by future mobile communication. So let us take a look at the picture, and we can see that there are three main use cases. The first one is EMBB, which stands for Enhanced Mobile Broadband. A second one on the left is MMTC, which is Massive Machine Type Communication, and also URLLC, which is ultra reliable low latency communication. So let's briefly talk about each of them. EMBB corresponds to a more or less straightforward evolution of the mobile broadband services of today, and it makes even larger data volumes and further enhanced user experience. So by supporting even higher data rates, which means we can transfer our media or our streaming in much better quality and much faster. So that's the first one, EMBB. The second one, MMTC, corresponds to services that are characterized by a massive number of devices, For example, remote sensors, actuators, and monitoring of various equipment. Key requirements for such services include very low device cost and very low device energy consumption, allowing for very long device battery life of up to like 20 years. Typically, each device consumes and generates only a relatively small amount of data. That is, support high data rates is not of the big importance. So uh, basically, we can say NMTC is something like for uh, IoT devices. And the last one, which is URLC, is uh, another key component. So for URLC services, we envision to require a very, very high reliability. So we want to use 5G in context of URLC for traffic safety, for automatic control, and for factory automation. So basically, the applications that are pertaining to these three different use cases are shown in this triangle. So the first one was eMBB, and we say that we will have extremely high data rate file transfers, 3D video, 4K screens, and for URLC will have something like self-driving cars, mission-critical services, and industrial and vehicular automation, where for MMTC, we expect to have big sensor networks or IoT. And let us talk a little bit about 5G new radio standardization. So on a figure here, you can see the relationship between different organizations involved in setting the regulatory and technical conditions for mobile systems. The figure also shows the mobile industry view, where vendors here develop products, place them on market, and negotiate with operators who should deploy the mobile system. This process of deployment relies heavily on the technical standards, which are developed by so-called SDO, Standard Developing Organization. And for example, in Europe, those organization is called ETSI, ETSI, and it's producing so-called harmonized standards used for product certification based on the mandate from the regulators, in this case, the European Commission. So these standards are also used for certification in many other countries outside of the Europe. Here you can see that full arrows uh, indicate the formal documentation such as technical standard, recommendation, and regulatory mandates that define technology and different regulation. And dashed arrows, such as here, show more indirect involvement. For example, some statements or white papers or some workshops. Um, Then about the after regularization, what comes next is actually the standards, the requirements that we want to impose on 5G systems. And on this diagram, we can see key performance indicators. So from the top to clockwise, first one is experience data rate. Second one is spectrum efficiency, then mobility, latency, connection density, network energy efficiency, area capacity, and peak data rate. So we can see that uh, we want to increase the data rates about like uh, 10 times here, so peak data rate by 20 and experience data rate by 10. Uh, the spectrum efficiency we want to increase by 3 times, but actually it is also might be not that possible because, as we'll talk later, the spectrum efficiency is actually very close to its limit. Then the mobility. Currently, the peak mobility that can be handled by 4G is 350 kilometers per hour, and we want to extend it to 500 kilometers per hour. Latency should be reduced by 10 times, so from 10 millisecond to 1 millisecond. Connection density should be increased by an order. Uh, Network energy efficiency, so it should be increased by 100 times, which means that we hope that battery lifetime would be 100 times larger, which is of course a very strict requirement. And also the area capacity should grow. Um, More details, you can check this table, so you can press on pause and check out the exact requirements, technical requirements for 5G system. And here we can see how those KPIs are important for different use cases. So the green one is enhanced mobile broadband, or EMBB. And for EMBB, we can see that energy efficiency, network energy efficiency, area traffic capacity, data rate, experience data rate, spectrum efficiency, and mobility are of the high importance, but latency and connection density are of less importance. While for machine type communications, we hope for increased energy efficiency, because those should be sensor networks and hence the battery life should be increased. And of course, connection density, that's equivalent meaning of the massive in MMTC. And for ultra reliable, we hope that we have a very low latency for very high mobility, while the data rates should not play of that much importance. Okay, and the last one in this introduction are the key innovations of 5G. So basically, we can 5G has a lot of different technologies incorporated, and they can be roughly classified in three different categories. The first one is spectral and energy efficiency. The second one is new spectrum. And the third one is new network architecture. So in this tutorial, I will go through each of these technologies, and we'll begin with the new spectrum one, since that's the most bottom in terms of layer technologies. And we'll talk about millimeter wave bands and different techniques like spectrum sharing or carrier aggregation.